my name is Analytical. Let's begin with what is titration. Titration is a method used to find out the concentration of an unknown solution by using a solution with a known concentration. In this process, the known solution called the titrants is slowly added from a burette to the unknown solutions called the analyte until the reaction is complete. By measuring how much of the titrants was used, we can calculate the concentration of the unknown solution. Usually, an indicator is added to signal when the reaction has reached the endpoint. Apparatus that use in titration. Titration relies on several key tools to ensure precise measurement and mixing of solution. The burette is a long graduated tube equipped with a stopcock at its base, allowing controlled dispensing of a non-solution titrants into the analyte solution. This enables accurate measurement of the volume added during the titration process. The conical flask or Erlenmeyer flask hold the analyte solution during titration. Its unique shape with a narrow neck and flat bottom facilitates swirling without splashing, ensuring true mixing of the solution being titrated. A retort stand provided essential support for the burette, consisting of a vertical metal rod attached to a stable base and equipped with a clamp. It holds the burette securely above the conical flask. This setup prevents accidental spills and ensures precise delivery of the titrants into the analyte solution. To transfer precise volume of liquid, a bulb pipette is employed, typically made from rubber or plastic. The bulb pipettes allow the analyte to draw in the analyte solution and dispense it drop by drop into the conical flask before titration begins. This controlled delivery is crucial for accurate measurement and calculation of the unknown solution concentration. Together, these apparatus play a critical role in the titration process, providing scientists and research with the tools needed to determine the concentration of unknown solution reliable and with confidence.
There are specific ways to clean the apparatus, for example, for use. First, for the initial rinse, you need to use distilled water to remove visible residue, and then you can use detergent wash to clean with mild detergent solution and brush if needed, and avoid abrasive materials because it might break the apparatus. And then rinse with tap water, truly rinse to remove detergent, and lastly rinse with distilled water to multiple rinse to remove impurities. Then, after using it, we need to empty the residual solution, which is pour out any remaining solution from the apparatus, and then rinse with tap water. Rinse thoroughly to remove residual chemicals. Then use detergent wash. Use similar detergent solution to clean the apparatus. Scrub with appropriate brushes as needed. And then rinse with tap water, and rinse again to remove any detergent. Lastly, rinse with distilled water. Perform several rinses to ensure complete removal of impurities. And then we will move to method to titrate. For step 1, preparation to clean the apparatus. Ensure all titration apparatus, burette, pipette, and flask are clean and dry. And then prepare the solution. Prepare the titrant solution in the burette. Prepare the analyte solution in the clean flask, and add a few drops of appropriate indicator to the analyte solution. For step 2, set up apparatus first. Fill the burette. Rinse the burette with the titrant solution. Fill the burette with the titrant solution, ensuring no air bubbles. Record the initial volume of the titrant. Then, prepare the flask. Measure the precise volume of the analyte solution using a pipette and transfer it to the flask. And lastly, add a few drops of indicator to the flask. The titration begins at step 3. Place the flask containing the analyte solution on the white surface to observe the color change clearly. Slowly add the titrant from the burette to the flask while constantly swirling the flask. While approaching the endpoint, as the endpoint nears, add the titrant dropwise to observe the color change more precisely. Determine the endpoint. The endpoint is reached when the indicator causes a sustained color change in the solution. Record the final volume or the titrant in the burette. After we're done with the titration, on step 4, calculate the volume or the titrant used by subtract the initial volume from the final volume of the titrant to determine the volume used. Then also determine the concentration by using the titration formula, and 1V1 equals to M2V2. Last but not least, for step 5, repeat the titration. Perform at least 3 titration to ensure accuracy and consistency. Calculate the average volume of titrant used for precise result.
Here are the examples of the results based on the titration involving sodium carbonate NaCO3 as the analyte and hydrochloric acid HCl as the titrate solvent. The indicator used in this experiment where to determine the color changes is the methyl orange. At the end of the titration, the data obtained can be used to calculate the volume of hydrochloric acid used during the titration by subtracting the final burette reading with the initial burette reading. The final burette reading can be recorded once the indicator in the HCl solution turns color from yellow to light pink. From the data shown in the table, we can see that the first, second, and third reading of the volume of HCl used in the titration are almost the same. This shows that the sodium bicarbonate used are in a good state, resulting in a good and constant final reading. Not only in educational purposes, titration are also widely used in other industries as titration ensure compliance with industry standards, enhance product quality, and maintain safety. For example, as we know, titration are used in the pharmaceutical industry to ensure the correct dosage of active ingredients in the drug formulation and to verify the purity of raw materials and finished products in the quality control. Titration are also used in food and beverage industry to measure the acidity, pH of products like wine, dairy, and soft drinks, and acts as a nutrient analysis in food products. Lastly, titration also helps in the environmental monitoring where the water quality testing and air quality control are done using the titration method. To sum up, titration is a fundamental analytical method with a pivotal role in various industries. Its precision and reliability make it indispensable for ensuring quality and compliance. Titration became one of the main helpers in certain industries, such as ensure the accurate dosage. Formulations in the pharmaceutical industry helps assess water quality in environmental monitoring and ensures product consistency and safety by measuring acidity, alkalinity, and other key parameters in the food and beverage industry. The widespread application of titration underscores its importance in maintaining industry standards and protecting public health.